Somewhere out there, in a universe we've barely begun to map, there might be a planet better than this one. Not richer, not prettier. Better at the one thing Earth claims to do best: hosting life. We call ourselves the lucky planet. The one with oceans, with air, with a sun that doesn't burn too hot or too cold. The Goldilocks world. But what if Goldilocks just settled? What if she never actually checked the other rooms? Scientists have started asking that question seriously. And when they built, on paper, the planet life would actually choose if it had options. Flatter oceans, a gentler star, a longer, steadier day. They gave it a name. Hestia, goddess of the hearth, the keeper of home. And when you place Earth next to her, something uncomfortable happens. Earth starts to look less like a paradise, and more like a planet that barely made the cut. Stay with me, because by the end of this, the ground you love so much might start to feel a little less like home and a little more like the runner-up. Let's be honest about what Hestia actually is, before we go any further. She isn't a planet anyone has found. No telescope has ever caught her shadow crossing a star. Hestia is a thought experiment, one of the most careful ones in modern astrobiology, and the question behind her is deceptively simple. If life is what we're searching for out there, why do we keep measuring every new world against Earth? Earth isn't necessarily the best planet for life. Earth is just the only one we've seen up close. That idea has a name now: superhabitability. It was proposed by researchers including astrobiologist Renee Heller, who argued that a planet could, in principle, host more life and more complex life than Earth does. Not by being Earth's twin, but by fixing the parts of Earth that quietly work against life. Hestia is what you get when you take that argument and build a whole world around it. So picture her. Start with the star she orbits. Not a yellow star like our sun, an orange dwarf. Smaller, cooler, dimmer. And here's the part that should stop you. Orange dwarfs can burn steadily for up to 70 billion years. Our sun will last about 10. Life on Earth has maybe 1 billion years left before the sun brightens enough to boil the oceans away. A planet around an orange dwarf wouldn't just have more time for life to exist. It would have more time for life to become something extraordinary. More time to evolve, to branch, to build nervous systems and cities and languages over and over again for 7 times longer than our entire story has taken. Now picture the surface. Earth's oceans plunge down as far as 11 kilometers in the Mariana Trench, a darkness so total, so crushing, that almost nothing lives there. Most of our ocean floor is a cold, black desert. Hestia's oceans are shallow, barely 200 meters deep, on average, across the whole planet, shallow enough for sunlight to reach nearly every square meter of seabed. On Earth, life clusters where light can reach it: the surface, the reefs, the coastlines. On Hestia, almost the entire ocean is that zone, the productive zone, the zone where photosynthesis and everything that feeds on it can actually happen. And instead of Earth's arrangement, a handful of enormous continents surrounded by ocean, Hestia is an archipelago world. Thousands upon thousands of islands scattered across those shallow seas with roughly 45 times more coastline than Earth has. Coastlines are where Earth's most productive ecosystems already live. Estuaries, reefs, tidal zones, the places where land and water trade nutrients back and forth. Hestia doesn't have a little bit of that. She's made almost entirely of it. Then there's the air itself, a thicker atmosphere than Earth's, denser, holding heat more evenly, smoothing out the difference between day and night, between poles and equator. No brutal deserts baking under direct sun for months. No frozen wastelands locked in permanent polar night. A climate with far fewer extremes to survive, which means far more of the planet is actually livable, instead of just technically present. Even her length of day works in life's favor. A slower spin, something closer to 36 hours instead of 24, giving ecosystems longer, gentler cycles instead of Earth's constant, rapid churn between light and dark. Put all of it together, and the researchers who model these numbers arrive at something almost dizzying. Not just more life, orders of magnitude more life. Some estimates suggest a world like Hestia could support complex species numbering in the hundreds of millions, compared to the roughly 2 million known species we've cataloged here. 2 orders of magnitude, 100 times the biodiversity, on a planet built to remove almost every obstacle Earth still puts in life's way. I want to be careful here, because this is the part where it would be easy to slip into science fiction instead of science. Hestia has never been observed. No mission has ever confirmed a world like her exists. She is a model, a rigorous, deliberately extreme model, built by scientists to ask an honest question. If Earth isn't the ceiling for habitability, what would the ceiling actually look like? She's less a place and more a mirror, held up to the planet under your feet so you can finally see its edges. And once you see those edges, it's hard to unsee them, because for our entire history, we've told ourselves a story where Earth is the exception, the rare good place in a universe mostly made of hostile ones. And that story isn't wrong exactly. Earth really did make life possible. It's just that possible and optimal were never the same word. We've been calling this planet a miracle for so long we forgot to ask whether it was actually the best miracle available, or just the only one we happened to be born on. So let's turn the mirror around fully and look at Earth the way Hestia forces us to look at her. Not as the blue marble in the photographs, as real estate, as livable space, square kilometer by square kilometer. And the number that comes back is almost embarrassing. Start with the oceans, because they cover 71% of this planet's surface. 71%. That should mean Earth is mostly water world, mostly alive. But the ocean isn't one place. It's layers, and most of those layers are closer to a graveyard than a garden. Below about 200 meters, sunlight can't penetrate strongly enough for photosynthesis anymore. Marine biologists call everything past that point the aphotic zone, the without light zone. And the aphotic zone isn't a sliver of the ocean, it's the vast majority of it. The average ocean depth on Earth is around 3,700 meters. Almost all of that column, top to bottom, is cold, dark, and nearly empty, aside from scattered life adapted to feed on whatever sinks down from above. We call Earth an ocean planet. Really, we live on a thin, sunlit film stretched over an enormous, dark abyss. Now go to land, and it doesn't get much better. About a third of Earth's land surface is desert or arid enough to be functionally hostile to most complex life. The Sahara, the Arabian deserts, the Gobi, the vast dry stretches of Australia and the American Southwest. Add the polar regions, Antarctica and the Arctic, locked under ice or permafrost for most or all of the year, and you're removing enormous slices of the map before a single ecosystem gets a real chance. Then there are the mountain ranges, the high-altitude zones where oxygen thins and temperatures drop fast enough to make survival its own specialty. None of these places are lifeless. Life is stubborn, and it has found footholds nearly everywhere. But footholds aren't flourishing. A tardigrade surviving in Antarctic moss is not the same as a coral reef teeming with 10,000 interconnected species. When researchers actually try to add this up, usable, temperate, resource-rich, biologically productive land and shallow water combined, the honest estimate is that only a modest fraction of Earth's total surface is doing the heavy lifting for the planet's biodiversity. The rest is technically part of Earth's habitable zone in the astronomical sense, technically bathed in liquid water and mild temperatures somewhere on the globe. But locally up close, Most of this planet is closer to inhospitable than paradise. And that's before we even mention the wobble. Earth's axial tilt gives us seasons, beautiful, dramatic, the changing of leaves and migrations of animals, but also brutal winters that empty out entire ecosystems for months at a time, and summers so intense in some regions that survival becomes a full-time occupation for anything living there. Hestia's gentler axis, her steadier orange dwarf light, sidesteps almost all of that. No harsh winters wiping out the food chain every year. No desperate migrations across a planet chasing a livable temperature that keeps moving. Here's what I find strange, sitting with all of this. We grew up thinking of Earth as generous, abundant, and in the story of the universe, compared to the sterile, radiation-blasted rocks we've found orbiting most other stars, it absolutely is. But generous compared to nothing is not the same as generous, full stop. Earth gave life a chance. It never promised life an easy one. Most of this planet's surface, its deep oceans, its deserts, its ice, its extremes, has spent 4 billion years quietly working against the very thing we love to call this planet's greatest achievement. Life on Earth didn't flourish because the planet made it easy. Life on Earth flourished because it had no other option, and it fought for every inch of the narrow, livable margins this world actually offered. That's not a small thing. In some ways, it might be the more impressive story, but it's not the story of an ideal world. It's the story of life succeeding despite its home, not because of it. Think about what that actually means for evolution itself. Every ice age that scraped the northern hemisphere clean, every mass extinction triggered by an asteroid or a supervolcano or a runaway greenhouse, every desert that swallowed a once green landscape. Each of those events reset the board, erased millions of years of progress, and forced whatever survived to start climbing again from somewhere lower down. A planet like Hestia, gentler, steadier, with fewer of these resets built into its basic geography and orbit, wouldn't just have more habitable space. It would have fewer excuses to burn 4 billion years of work back down to zero. And once you know a world like that could exist, at least on paper, it becomes almost impossible to keep telling ourselves that Earth was always the best this universe had to offer. Here's the question that actually matters once the shock of comparison wears off. If Hestia is only a model, is there anything real out there that even comes close? And the answer, quietly, is yes. Not a perfect match. Nothing this tidy exists in nature, but astronomers have already found real, confirmed worlds that lean in Hestia's direction, and looking at them tells us something about why her blueprint isn't just wishful thinking. Take Kepler 442b, a planet a little over 1,000 light-years away, orbiting a star cooler and dimmer than our Sun. It sits in its star's habitable zone, and some habitability models rank it among the most promising rocky worlds we've found for hosting liquid water. Or Kepler 1649c, roughly 300 light-years out, nearly Earth-sized, orbiting a small, cool star, and landing almost exactly in the zone where temperatures could allow oceans instead of ice or steam. None of these are confirmed to have life. We can't even confirm they have atmospheres yet, not with certainty. But they exist. They're not thought experiments, and their stars share something important with Hestia's imagined orange dwarf. They're smaller, cooler, and built to burn for a very, very long time. That detail is the real heart of the Hestia idea. More than the shallow oceans or the archipelagos, it's the star. Sun-like yellow stars are actually something of a poor choice for long-term habitability, and that's a strange sentence to sit with, because our entire existence depends on one. Yellow stars burn hot and comparatively fast, and they don't stay stable forever. Ours is already about halfway through its life, and it's been slowly, steadily brightening the whole time, which is part of why Earth's window for complex life is closer to its end than its beginning, cosmically speaking. Red dwarfs, the smallest and most common stars in the galaxy, solve the lifespan problem almost too well. Some could burn for over 1 trillion years, but they come with their own brutal cost. Young red dwarfs are violent, prone to enormous flares that blast their nearby planets with radiation intense enough to strip away atmospheres entirely. A planet close enough to a red dwarf to stay warm is often close enough to get sterilized instead. Orange dwarfs, sometimes called K-type stars, sit in the gap between those two extremes. Calmer than red dwarfs, longer-lived than yellow ones, stable enough for long enough that a planet in their habitable zone could have not just millions but billions of extra years for evolution to work with. And evolution, given enough time, doesn't just produce more life. It produces stranger life, more specialized life, more complex nervous systems, more elaborate ecosystems layered on top of each other, generation after generation, with no asteroid or supernova forcing a reset. Time, it turns out, might be the single most undervalued ingredient in the entire search for life beyond Earth. We talk about water, we talk about temperature, we talk about atmospheres. We talk far less about the simple, almost boring variable of just how long a world gets left alone to cook. And this is where the Hestia thought experiment stops being pure fantasy and starts becoming a genuine research tool. By asking what an ideal world would look like, scientists aren't dreaming up science fiction. They're building a target, a profile to search for, when the next generation of space telescopes scan distant systems for signs of orange dwarf stars with rocky planets in their habitable zones, shallow oceans, dense atmospheres. They'll be looking, whether they use the name or not, for something Hestia-shaped. The fictional planet becomes a search pattern, a North Star for people looking for the closest thing to a needle in the largest haystack humanity has ever tried to search. There's also a quieter implication buried in all of this, one that doesn't get talked about as often as it should. If superhabitable worlds exist, and if orange dwarfs really do give life this much more room and this much more time to work with, then in the grand statistics of the galaxy, Earth might not just be a middling planet. It might be one of the younger, less developed ones by comparison. Not because anything is wrong with us, but because our star simply hasn't given evolution the runway that a calmer, longer-lived sun could offer somewhere else. Somewhere, potentially, life has had billions of years longer than we have to figure out what it's doing. That's a strange thought to hold next to the one we usually carry around, the one where humanity is the most advanced thing evolution has managed to produce anywhere. Maybe we're not the finish line. Maybe we're not even particularly far down the track. That thought leads somewhere uncomfortable if you actually follow it. Because if there are worlds out there with a head start of 1 billion years, 2 billion years, even more, then where is everyone? This is the question astrophysicist Enrico Fermi asked, almost as a throwaway remark back in 1950, and it's haunted the field ever since. If the universe is old enough, and if superhabitable worlds like Hestia can exist, and if some of them have had this much extra time to cook up complexity, intelligence, maybe even civilizations that build things visible across space, why does the sky stay silent? Why hasn't anyone called? There are a few honest answers, and none of them are comfortable. One possibility is what researchers sometimes call the Great Filter, the idea that somewhere between simple chemistry and a civilization capable of reaching the stars, there's a bottleneck, a step that's brutally, statistically hard to survive. Maybe it's the jump from simple cells to complex ones, a transition that took Earth nearly 2 billion years and, as far as we know, happened only once. Maybe it's the jump from intelligence to technology. Or maybe, and this is the version that keeps some scientists up at night, The filter isn't behind us. Maybe it's still ahead. Maybe every civilization that gets close enough to reach the stars eventually finds a way to destroy itself first, and the silence out there isn't a lack of life. It's a graveyard we simply haven't learned to read yet. Hestia complicates this puzzle in an interesting way. If a genuinely super-habitable world existed around an orange dwarf, it wouldn't just support more life. Its longer, calmer stellar lifespan means any civilization that did emerge there would have had a longer, calmer stretch of time to grow into something that could actually announce itself. Fewer supervolcanoes forcing a reset, fewer catastrophic climate swings, more generations, more accumulated knowledge passed down without the kind of civilization-ending disaster that keeps punctuating our own history. In theory, a Hestia-like world isn't just more likely to harbor life, it's more likely to harbor old life. Life that's had the luxury of time we've never been given. And yet, the silence remains, which means either these worlds are rarer than the models suggest, or intelligence itself is far harder to reach than we assume, even with every advantage stacked in its favor, or something else entirely is going on that our current science hasn't found language for yet. Every answer here is speculation dressed up as reasoning, and I want to be honest about that, because this is exactly the kind of question where it's tempting to sound more certain than the evidence allows. There's a quieter, more practical version of this search happening right now, one that doesn't require answering the Fermi paradox at all. Missions like the James Webb Space Telescope are already studying the atmospheres of nearby exoplanets, looking for chemical fingerprints of biology, gases like oxygen or methane existing together in combinations hard to explain without something alive producing them. None of the candidates checked so far have delivered a clear, undisputed signal. But the search itself has shifted quietly in the direction Hestia points toward. Astronomers increasingly talk about prioritizing K-type, orange dwarf systems for these atmospheric surveys, for the same stability argument that built Hestia's blueprint. The thought experiment and the real search have started to converge. Here's what I keep circling back to, though. This entire exercise, imagining Hestia, comparing her to Earth, running the numbers on orange dwarfs and shallow seas and archipelagos, isn't really about finding a better planet. We can't move there. It doesn't exist, not in any confirmed sense, and even if it did, it would be so far away that the light leaving it today wouldn't reach us for centuries. The point was never relocation. The point was recalibration, learning to see the planet we actually have with clearer eyes, instead of the sentimental ones we inherited from childhood, globes, and postcards of the Earth from space. Because here's the strange twist in all of this. Earth's limitations, the deep dark oceans, the punishing deserts, the axial wobble, the yellow star quietly burning down its fuel a little faster than we'd like, aren't flaws in the story of life here. They're the actual plot. Every species that made it, every ecosystem that clawed out a foothold in a narrow, livable margin surrounded by hostility on every side, did it despite conditions that a planet like Hestia would have simply handed over for free. That's not nothing. That might be one of the most quietly remarkable facts in the entire universe. Not that Earth is the best possible home, but that anything as complicated, as strange, as stubborn as us managed to happen here at all. Let's actually try to stand there for a second. Not as scientists reading a model, but as something alive on the surface of Hestia, looking up. The light would be different first. An orange dwarf doesn't burn white hot like our sun. It glows deeper, warmer, closer to the color of a late afternoon that never quite ends. Every day on Hestia would carry that ambercast, stretched out over 36 hours instead of 24, which means sunrises and sunsets that linger instead of rushing past you the way ours do. A slower planet in the most literal sense. Slower light, slower spin, slower everything except, strangely, evolution itself, which would have all the time in the world to speed up. Now put yourself at the edge of one of those shallow seas, not staring into a dark trench, the way you would here, but standing at the edge of water so shallow and so lit that you could, in theory, see almost to the bottom, no matter where you stood on the whole planet. Every inch of that ocean doing what only a thin sliver of Earth's ocean gets to do, turning sunlight directly into life. Thousands of islands breaking the water's surface in every direction, an archipelago so dense that land and sea would barely feel like separate categories anymore. Just an endless, productive in-between. Here's the part that's easy to miss in all the numbers. A world like that wouldn't just have more species, it would have more competition. More life packed into more usable space almost always means more pressure, more predators, more rivals for the same patch of sunlit reef. Abundance doesn't remove struggle, it just changes its shape. On Earth, life competes for scarce livable ground, scattered across a mostly hostile planet. On Hestia, life would compete inside abundance itself, an ocean so generous that nothing would ever be handed the excuse of empty space. And that raises a question researchers who study this actually take seriously. Would more habitable space really produce smarter life or just more life? Some evolutionary biologists argue intelligence isn't a reward for easy conditions. It's often a response to scarcity, to unpredictability, to environments harsh enough that raw instinct stops being enough and something more flexible has to take over. Our own ancestors didn't evolve big brains in a paradise. They evolved them in East Africa, through shifting climates, disappearing forests, unpredictable seasons that punished anything too rigid to adapt. Struggle, in other words, might not just be a cost life pays on a planet like Earth. It might be part of what built the very thing capable of asking these questions in the first place. So Hestia complicates her own promise the moment you look closely enough. Yes, more habitable space, more time, more stable conditions almost certainly means more life, more diversity, more sheer biomass than Earth could ever support. But whether that translates into more minds like ours, more curiosity, more creatures capable of standing on a beach and wondering what's on the other side of the water, is a far less certain thing. Abundance might grow a jungle. It might not grow a philosopher. I keep turning that over because it flips the entire premise on its head. We built Hestia as the planet that fixes everything wrong with Earth. And on paper, she does. But some of what's wrong with Earth, the harsh margins, the narrow bands of livability, the constant pressure to adapt or disappear, might be exactly the mechanism that produced a species capable of imagining a better planet in the first place. Hestia might host more life than we can comprehend. She might never host anything that comprehends her back. There's a strange kind of symmetry buried in that thought. The very qualities that make Earth look, on paper, like the lesser planet, the deep trenches, the punishing deserts, the axis that tilts us into brutal winters, might be the same qualities responsible for the fact that anyone is here at all to run the comparison. Hestia was built by removing Earth's obstacles, but nobody ever removes an obstacle for free. Every barrier this planet ever threw at something alive was also a filter, and filters by definition don't just block, they select. They shape whatever manages to slip through into something sharper, more adaptable, more capable than it would have been without the resistance. So maybe the real question was never whether Hestia is better than Earth. On raw numbers, on livable space, On time and stability, she almost certainly is. The real question is what better was ever supposed to mean. A planet optimized for the sheer quantity of life it can hold. Or a planet that, almost by accident, through billions of years of near misses and narrow margins, produced something willing to ask which one of them wins. There's one more piece of this that I think about more than any of the numbers. The name itself. Hestia. Not a warrior god, not a god of thunder or war or the sea. The goddess of the hearth, of home, of the fire kept burning at the center of a house so that whoever lived there always had somewhere warm to return to. Scientists could have named this hypothetical world anything. A number, a code, a string of letters like the ones real exoplanets get stuck with. Instead, they reached for a goddess whose entire mythology is about staying, about tending something quietly, faithfully, so it never goes cold. And there's an irony in that choice that I don't think anyone intended, but that's impossible to ignore once you notice it. Hestia, the planet, doesn't exist. Nobody has ever stood on her shallow seas or felt her slower 36-hour days pass overhead. She has no history, no mornings, no first creature that ever crawled out of her gentle tide pools and looked back at where it came from. She is, in the truest sense, a planet with no hearth at all. Just a blueprint. A beautiful, empty design, waiting for a story that was never written, because there was never anyone there to write it. Earth, on the other hand, whatever her flaws, whatever percentage of her surface is dark trench or frozen wasteland or scorched desert, is the only place in the entire universe we know of where the fire was actually lit. Where something did crawl out of shallow water, however narrow that water was, where seasons, however brutal, force something to adapt instead of vanish, where a magnetic field, however unevenly it protects us, has held steady enough, for long enough, for every single thing you've ever loved to exist at all. Every person you've ever known, every mistake you've ever made, every sunset you've ever stopped to actually look at. All of it happened here on the planet with the deep trenches and the punishing deserts and the wobbling axis because this is the one place where the hearth actually got built. Maybe that's the twist underneath the entire comparison. We spent this whole video measuring Earth against a planet that could, in theory, hold more life, more time, more ease. And by almost every metric, Hestia wins. But Hestia is a model, a ceiling drawn on paper to show us how far short we fall. Earth is not a model. Earth is the actual, messy, imperfect place where the experiment ran, where the fire caught, where 4 billion years of near misses somehow, against every reasonable expectation, produce something capable of naming a fictional planet after the goddess of home, and then noticing quietly that the name might have been describing the wrong planet the entire time. We are not the passengers of a lesser world. We are the proof that a harder one can still work. That's not the story of settling. That's not Goldilocks giving up and taking the first room she found. That's a species that got the harshest draw available and built cities, and music, and questions like this one anyway. Hestia shows us what perfect might look like. Earth shows us what perseverance actually looks like, up close, from the inside, one narrow margin at a time. So the next time you walk outside, past the ocean you'll never see the bottom of, under the sun that's already halfway through its life, on an axis that's going to tilt you into another difficult winter eventually. Remember what that discomfort actually is. Not proof this planet failed you. Proof this planet asked something of you and something in your ancestors, all the way back to the first fragile thing that crawled out of shallow, unforgiving water, answered. There's something almost tender about that once you sit with it long enough. We spend so much time online in comparisons, in rankings, in videos exactly like this one, measuring what we have against what could theoretically be better. A nicer apartment, a calmer version of our own lives, a planet with gentler seas and a kinder sun. And there's nothing wrong with imagining those things. Hestia herself only exists because scientists were willing to ask what better could look like. But somewhere in that habit of comparison, it's easy to forget that the thing you're standing on, however flawed, however statistically outmatched by a planet that will never exist outside a research paper, is still the only place in the observable universe where the outcome of 4 billion years of difficulty was you. Not a hypothetical you. Not a modeled version optimized for ease. The actual one. Reading this, on the actual Earth, with its actual trenches and its actual deserts and its actual wobble, carrying whatever came before you far enough to reach this exact moment. If you've made it this far with me, comparing an entire planet you'll never see to the one you're actually standing on, I want to say thank you. Genuinely. That's not a small amount of time to spend thinking about shallow oceans and orange dwarf stars and a goddess who was never quite talking about the planet we assumed she was. It says something about you. So if you want more of this, more of these strange, quiet comparisons between the world we imagine and the one we actually live in, consider subscribing. We put something like this out every single day. And before you go, I want to know something. Not whether you'd move to Hestia if you could. That one's easy. I want to know what part of Earth's story, the trenches, the deserts, the wobble, the narrow margins life had to fight for, actually changed the way you see this planet by the end of this. Drop it in the comments. I read every single one, and I mean that, not as a line, but as something I actually do. Late at night, scrolling through what people who watch this were left thinking about. If this shifted anything for you, even slightly, do one thing for me. Share it with someone. Not because it needs to go viral, but because a thought like this lands differently when you're not the only one holding it. Send it to the person who always says Earth is boring compared to what's out there. Let them sit with the numbers for a minute. Let them decide for themselves whether boring is really the word for a planet that built something capable of imagining a better one. We'll keep doing this. Every day, another planet, another impossible number, another quiet reason to look at the ground beneath you a little differently than you did yesterday. Hestia was never real, but the questions she raised about this planet, the one under your feet right now, absolutely are. I'll see you in the next one.